Okay, so for the USB to RS-232, the serial, the USB to serial converter hardware, we're first going to do design up in our CAD softwares, and this means that we're going to, we're going to have our ICs, and we're just going to wire them, connect them together, and you see we've got our RS-232 transceiver chip, we've got our RS-232 port, and a bunch of resistors and LEDs and a connector for the power, etc. Okay, so once it's wired together, then we're going to then do a board design. So for the board layout, this is the PCB layout. These are the components, and this is how they are going to appear on the PCB. So we've got our serial port again, and we've got our two ICs, capacitors, LEDs, etc., and resistors up here. And just over here then is where the board is going to be compiled, and all the components are going to appear on it. So then once the PCB, the board, is satisfactory, we're then going to want to house it in an enclosure that's going to be fit for purpose as well, and so we need to look at that. Okay, so the interior then of our enclosure that we have in a different CAD software is this time now. This is what our enclosure is going to look like. So the plan is that, the PCB is going to be placed within the enclosure, and all of the inserts that are required for the power and for the data input, the USB and the serial inputs, they will all be done at the sides. So all of those cutouts that are required will be done in the design and then sent for manufacture. So at this point we'll be looking to have direct PC control over peripheral devices, and in order to accentuate that then we're going to design a HMI for that. So then with the HMI component that I have in Visual Basic, we'll be able to have greater control over inputs and outputs and be able to monitor them as such. So for the operator use and for engineer use. Okay, so for PLC control then, I've just got a little ladder logic program that I've input, and we'll just have a look at when we're offline right now, but if I put it online and program it, we can force the inputs on and look at the outputs. Now I'm using it not with an actual PLC, but I've got an emulation program running with it. So we'll go online anyway and we'll just see what happens. So you can see here that this is the emulation software that I'm talking about, Emulate 500, and I've set it to run. So I should be able to force the inputs on. They're both off at this point, and the output hasn't been activated. So simply I just force on, and you see the output has gone green, so it's the output is high. I'll just force off, and you can see the output goes off. And on this rung that we have here as well, this is off at this point, but again I can demonstrate a force on, and you see the output again has gone high, and when I force off, the output again has gone off. So you can see that the program is working and the emulation software is allowing it to work as well. In the PLC, it might be controlling a pneumatic circuit like the one that we have here, a very simple one that I've just put together briefly. If I put it to run, okay. Okay, so we've got the air supply here going to our 3-port two-way valve, and if it's button operated, so if I actuate it, there we go, it's a spring return. So again, the air goes through momentarily, actuates the cylinder, and then it returns to the rest position again. Okay, here's just a simple microcontroller program. It's written in assembly. And I'm just going to assemble it right now. Okay, so okay, that's assembled and that's ready to go. So what I'm going to do then is I'm going to program the PIC controller, which is on this PIC controller board here. It's powered up, as you can see, with the LED light on, and here's the RS232 cable, and this is actually the PIC controller right there in the center. Maybe difficult to see it, but in any case, what I'm going to do is I am going to program, I'm going to write the program to the PIC controller, and then we're going to look at the outputs. So just going to quickly select the file. That's the one we just compiled. Okay, and just write it then to the, just on the controller board, you have two options, to run or to program, and I have to switch it to program now. Okay, so the blinking light there indicates that it's ready for programming. So I'll just go again and write the program to the controller. Okay, it's ready to go. And if I go back now to the controller and switch to program, you should see something happen with the LED. And there you go, that's what the program is designed to do. It's very simple, just to actuate an output. Here in this case it's an LED.